Yeah, okay. Is it better, Anthony?
Win. Perfect.
Okay, then perfect for me too. And sorry for that. It's not like we were missing some critical content until now. So yes, SC0212M is the working group on AES67 development. So it's not the working group that wrote the first version of AES67, but it is the group that is maintaining the standard and its adoption, mainly by organizing plugfests and by trying to solve the user problems with AES67, and one of them being the very purpose of this talk today. So the group was initiated in October 2010. Well, the project of AES67 was initiated in October of 2010 as project X192. Those of you who can remember, which led to the publication of the first version of AES67 for September 2013. And in October 2014 was the first plugfest in Munich, where we had a few number of manufacturers trying to test their AES67 implementations and fixing the first bugs. Then in 2015, we outputted another version of the AES67 standard, and we had another plugfest, this time in Washington at the NPR. Then in September 2017, it was the publication of ST2110, which is the standard from the SMPTE, and which is using AES67 as the basis for the architecture and audio transport. We also had, during the year 2017, a plugfest at the BBC. Then in 2018, AES67 2018 was published with the PICs, the protocol implementation conformance standard, I think. So those PICs are basically helping users and developers of AES67 into a simple checklist to see what is conformance statement. Thank you, John. So yeah, performance implementation, protocol implementation conformance statement, helping users and developers to basically test their devices and check that they are conforming to the AES67 standard. And of course, last but not least, the ME for the development of synchronized multi-channel and compressed audio transport over IP network was given to the AES and other organizations as well. AES67 is a huge milestone in the road of adopting networks for media infrastructures. So SC0212 has had some publications, which is the first AES standard and its revisions, the Munich Plugfest report, the Washington Plugfest report, the London Plugfest report, of course, and a publication in 2016 about the PDP parameters for AES67 and ST2059-2, which is about synchronizing and maybe configuring PTP over the network to accommodate different profiles, PTP profiles of the ones that are prescribed in AES67. And then in 2019 was the PIC summary, which is used by many manufacturers to simply and quickly present the AES67 capabilities of their device. So AES67 is based on LAN. And of course, now we are more and more talking about using AES67 beyond the LAN. Mainly trying to use the principle and the AES67 devices, but on complex networks, which are the internet, VPN, or some other type of networks. And those networks are typically called WAN, as wide area network. So we could define the WAN as a way to interconnect local area networks, but also to connect to other endpoints. So for instance, we could have an endpoint in a data center, which would be a virtual endpoint and which would be WAN ready, or an endpoint directly connected to the internet via a gateway. This would be, for instance, a codec on a radio station, for instance, or a TV station that is connected via a VPN to another LAN. Either if it's via a leased line, the internet, or VPN, the problems are the same. And of course, the problems are encountered now more than ever, thanks to this little nasty thing that has been bugging us for the last 15 months, but also due to changes in the way of producing content. So of course, when you produce content offline, or you don't really need live audio and you don't really need AES67, but more and more journalists or musicians are asked to contribute in real time. This meeting is an example of it, of course, but obviously not using AES67 yet. And this is, of course, an ongoing work on this on the standard committee. So now we do not have an SC0212 publication on that. We will have soon, but the goal is to answer those really questions. So what can I do with my AES67 devices? What can I add to my networks to strengthen the connection? So if I cannot use my network as such, because the connection or the quality is not enough, what can I do to improve this quality? And maybe what should manufacturers add to their equipment, to their AES67 equipments, for them to be WAN ready? I used to do that. This was work in progress, but the work has progressed up to the point that it's definitely coming soon. We are at the stage where the paper is close to the end of the first drafting. But of course, and it's one of the purpose of this very meeting, you are all welcome to participate in SC0212. This is an open working group. Well, I think you at least need to have some kind of relation with the AES67 devices. Okay, so internet is IP, so is AOIP, audio over IP. So isn't AES67 WAN ready by design? Meaning that, of course, IP is IP, but there are many different ways of seeing the IP. And as said before, AES67 was written to work on LAN, on local area networks. And I am sure you are hearing some construction work that just started for this meeting, but I hope that it is not.
Don't worry, this is Nicola. This is real life. You keep going. You're shut your door there. You just keep going, buddy.
Yeah, I wish I could shut my door. It's just the roller coaster. But anyway, so again, local area network. So those are typically small distances. And it's a private and controlled network. Mainly you own the LAN, you control what you put on your line, and you control what you restrict or what you authorize on your LAN. Those are all the constraints that AES67 was built on, and ST2110-30 was built on too. So hence the use of PTP for AES67 and the extensive use of multicast, which are two protocols and two ways of distributing information that is not at all that easy on a WAN, as we will see later. One on the other side is long distances, very long distances. It can be hundreds of kilometers or even thousands of kilometers. It is generally a leased or a public network, meaning that you will very rarely own the link, the physical link that you use for your WAN. And hence you will have limitations in terms of protocols and bandwidth. You may have limited bandwidth on your wide area networks, and you may have a limited number of protocols that are allowed on your wide area network. One typical wide area network that we are all using is the internet, and of course some protocols are forbidden on the internet, one of them being the multicast, so you cannot do multicast over the internet, for instance. So for those type of networks, the wide area networks, typically the real-time audio is transported using ASIP or DBU text 332.6, but you may want to go wider than that, and the way to you may want to get the benefit from the AES67 performances or features that you do not get with ASIP. So a wide area network is also a way. There are also many different levels of wide area network. So that's the one you own, like we will see for Eurosport, for instance. You have a dedicated team that is managing the WAN. You can put your own restrictions, and you can negotiate with your IT engineers into allowing or forbidding some protocols. You can borrow a wide area network. So you can borrow, and there are companies offering services like that. Then you have a service level agreement that will lead to you expecting some performances and your provider having to provide you such performances. And for many of us, it's just the internet. And then you are on your own, meaning that, of course, you can only act on the endpoints of your connection, the sender and the receiver, but you cannot act on what is in the middle, meaning the internet. And of course, if we talk about wide area network, if we talk about AES67 beyond the LAN, we will talk about the cloud as well. So virtualization software and cloud in data centers. So do I really need AES67? This is the first question to ask. And of course, you need AES67 if you need precise timing, for instance, to do lip sync, if you need PCM quality, and if you need low latency or close to real-time operations. If you don't need all of the above, then it might be easier to use another protocol. But let's say, okay, I want to use AES67. So I have to ask myself the question, what is the workflow? Can I compensate for latency? Do I need precise timing, and are the timestamps enough? Or do I need to share everything from site A to B? So if I'm connecting, for instance, on the first graphic that we saw, 2 different lines, do I need to share everything that are on those lines, or do I need to control what streams are shared between those 2 sites? So let's see the problem associated with wide area networking and some solutions, of course. So the first problem is the delay. And the delay comes from the limited speed of light in a fiber, which is granted a very high 200,000 kilometers per second. But when you are trying to get really low latency, it begins to add up. And it's 5 milliseconds for 1 kilometer. And when you look at the topology of some networks, for instance, this is the topology of the French Research Network, you can see that even on some, between some cities that are a few hundred kilometers apart, you may end up by working 1,000 kilometers of fibers just because there is no direct connections. And you can test it yourself. So I am based in Grenoble, in France, and Merging Technology, the company I'm working for, is based in Lausanne, and there are 200 kilometers. But when I do a ping, when I measure the round trip time of a packet coming and going from my home to the office, I get between 16 and 42 milliseconds, meaning that as an AES67 transmission, I would need at least to account for a packet delay of at least 42 milliseconds. And this is to account the geographic delay. So the packet flying through the fiber and the internet, and the packet delay variation, meaning that the packets will encounter some routers and some other devices that will have to deal with other types of traffic, and all of them, they will add variability in the delay, and they will most likely add delay in the delivery of the packets. Although AES67 recommends 20 milliseconds, and which is much more than enough on a LAN, on a WAN, we already see that AES67 recommendation will be needed to be much greater than that. For instance, here we had a test with the Ravenna team, and we had a webinar on that, and we did some transmission over the cloud with some virtual machine in Amazon Web Service servers, and coming and going from Lausanne to the Amazon Web Center, to the Amazon data center. I had to set my receive buffer to 333 milliseconds to receive my AES67. So this was just a rough test, not optimized at all. Then, of course, we got timing. If you want to synchronize between multiple sites, you have to share the same timing. And for that, you can use GNSS, for instance, GPS, or you can use PTP over the WAN. And they have both advantages and disadvantages. But the main way of doing synchronization right now is to use GPS clock and to use a PTP grandmaster by site synchronized to GPS. By doing this, you have both grandmasters that are exactly to the same clock, well, 30 nanosecond precise to the same clock, and you can share the stream via the internet. When you do that, you get the time that is shared with the devices, and you just have to set the receive buffer to the proper amount to account from the delay inside the cloud. But of course, the PTP masters are not the same. They are synchronized to GPS, but they are not the same. And for that, you can relate to RFC 7273, use the traceable keyword which is mentioned in the AES67 standard. You should use the timescale PTP to have the perfectly synced PTP, etc. So you have to take care of the clocking with much more deepness than you do with AES67 on the LAN. And then, of course, you will be losing packets. You lose packets on the WAN, you lose packet on the internet. This is how the internet was designed. In no way Ethernet was designed to be safe in transmitting packets. And all those TCP, the TCP protocol is all about alleviating and trying to recover the packet and ring congestion, etc. So you will lose packets, and unfortunately, AES67 does not answer this problematic, but ST2110 does. So in our report, we present the different ways of trying to reconstruct the stream of data when doing a transmission over an insecure line. We have, for instance, FEC, which is forward error connection. So you send just a bit of information along the mainstream to be able to recover missing packets, but you are only allowed to recover missing packet in a specific shape or sequence of losing data. You have restore SRT, which has automatic request protocols, meaning that when a receiver is missing a packet, it will ask the sender to send this packet back. And you have the ST22-7 technique, which is basically multiple pass streaming. You send the stream by two you send two times the same stream, but you send it via different passes. Of course, once again, when you're using the internet and you have a single ISP connections, like it is the case right now, for me, ST22-7 and multipass will not work at all. You could also use a gateway, and you could take stream from one side to the other and rely on the very gateway to do the tunneling. And those gateways could use protocols to recover missing packets. They could even transport multicast over the tunneling. It really depends on the offer of the gateway that you find. One of them being the use of a layer 2 VPN, which allows you to directly transport the Ethernet packets over the internet. And of course, there are so much more that will be definitely in the report that we are writing and trying to finish. So the good thing is that AES67 is based on IT standards. This means that it is using RTP, and RTP is widely used over the internet, and it does not require any transport-specific equipment. AVB, for instance, does require specific switches. AES67 does not, so AES67 is ready to be transported over the internet, over any WAN. But PTP is not. It's not designed for WAN, and so you need to take care about the clocking and to take care about really having the right clocking infrastructure with the right grandmaster synchronized to the right clock to be able to do this over the WAN. And multicast could be a bit tricky, especially if you do not the one that you're using does not belong to you, and you cannot mess with the switches and the infrastructure that you're using over the WAN. So once this is said, let's go over some user feedback, and let's start with Anthony. Anthony, I think you have slides to share.
Yes, I do. Well, let's see if we can get this thing going here. And I'm going to turn on the auto translator. All right. I'm now talking through the auto translator 10,000. All right. Let's hope it works. Thanks, everyone, for being here. Nikolai, you're a trooper. 10 points for talking through the noise. That is super hard to do. It is appreciated. All your hard work is very appreciated in your leadership in this group. And I just wanted to, express again, the sheer importance it is to have volunteers like yourself and the work that others do on this, standards committee and with these standards work in order to make all of this stuff possible. So I got a couple of slides. My name is Anthony. I'm an audioaholic. You can tell by the background stuff. They told me to start from the ground up, so I decided to take a chair position on the technical working group for grounding and shielding. I'm the chair of the Toronto Audio Engineering Society, and I work with the NMOS working group, and I like audio. So like I said, the Canadian Broadcasting Corporation, we consume a lot of AES standards, like just tons and tons of AES standards. We have multiple transmitters spread across the country, multiple provinces, different languages. We do everything in two languages. So there's a primary language, secondary language, whichever one you speak is relative to you, but it's all backed up. And we move a lot of channels of audio in the building. In the building, we move a lot of channels. We move a lot of AES3, we move a lot of analog, we move tons of absolutely everything. And it comes down to the grounding practices, the shielding, the connector practices, the stereo, the digital side of things, the multi-channel side of things, and now the IP side of things. As we move into the IP world, we start aggregating all of our different devices, and all of our different provinces started to get aggregated, into a centralization effort in order to make this stuff possible. So in order to move audio from computer to computer, you got to have some kind of standard and some kind of protocol. So, throughout the building, we used AES3. And, everybody, they say we move AES audio. I'm like, okay, well, that's great. But what you're actually saying is you're moving AES3, 2-channel audio. But there's more to AES, right? We have the AES67 and wherever we get from there. We have MADI. Nobody ever says, hey, we're moving AES, but it's MADI. And that's where we get beyond the land. And why is it important to us as broadcasters? Okay, well, here's a studio in northern Quebec. It's AES67 environment inside all of this product. It has a gateway, and it accesses Montreal, and it accesses Toronto. Intercom, interviews, bidirectional communication, in-ear monitoring, all of that stuff right now happens through proprietary gateways. But all of this stuff is connected to our LAN ecosystem. So the Canadian Broadcasting Corporation, we really invest heavily in making a full stack of operable products. And the reason why we need these things and these standards to get these operable products is, it needs to work once another, because we are doubling everything. And what Nicola was saying about dual link redundancy, well, that exists on every device. And I'm not talking about building one pyramid that has a media transport and some kind of control that's on our network. I'm talking tens of thousands of these devices. So we obviously need some type of way to hand it off from one thing to another and back and forth. So we have our private network, and our private network, has control over, all of the things that are behind our walled garden. And inside that walled garden, we can create AES67 presentations, and we can create AES67 playbacks, and we can create 2110 playbacks. And now with these standards, you can intermix these things. So this effort beyond the LAN, beyond the little tiny network that's, running your PA system, this is really LAN to LAN to LAN to LAN kind of best practices. And of course, it's you got to deal with the public internet on top of things. And like Nicola is saying, it's not something you can control, but it's something you can buffer and do things differently over. And this document is chocked full of those types of explanations. Somewhere in the middle, there's a solution. So professional societies like the AES, government organizations, private sector organizations, and user groups really, really come together to make this happen. And those connections connect in Canada. They connect people. Saskatoon connects to Regina, and Rimouski connects to Montreal, and these communities have conversations with one another. And as we add these links up, province to province, region to region, room to room, it gets massive. And in order to have some kind of ability to hand off audio from one thing to another, programmatically, it just, you start seeing the potential of why, a standard is super important to operational capabilities of a broadcast facility. Here, I just amplified that. There was another ring around this other ring of devices. These are devices that are on my network. So when you start dealing with the granularity of audio channels, it's a very astronomical project when you start dealing with it at scale. Now, as broadcasters are coming online with AES67 devices that are capable of 2110-30, we're starting to see the elimination of other AES standards, right? AES3 is starting to disappear. MADI is starting to disappear. And now it's just, well, here's your stream. There it is. Present it to me. And some of these things are treated like appliances. So when we talk about ground to cloud, cloud to cloud, cloud to pizza box that's sitting in a rack someplace, you can route to and from it. And when I say pizza box, it's like a pool. It's really like a pool. When you get these networks scaling, you can go from a wireless microphone to a video scope. Like it's just one connection. You can go from a video gateway to a server. You can go from any of these things. And when I say pool, you really just dump these multicasts and these unicasts into a pool. So it scales. Well, now I want to connect this pool to this pool and this pool to this pool. So, ultimately you have to dump a can of soup into that pool and pull it out someplace else. And that's really what these documents start doing, is they start really explaining, the common things that you can do to, guarantee some reliability on your network and transport them in order to have these super low latency conversations. And that's really what we're doing on a broadcast network at scale, is we're having these huge broadcast conversations. And it's me sitting in my studio and talking to some other person, and we are the customer that wants, full PCM audio all the time. And the other reason we need the full PCM audio is the output of the studio is fed from there. Sometimes the STL, the station transmitter link, is fed from there. So we are the consumer of that PCM audio. And as broadcasters, traditional terrestrial broadcasters, our web streams are consumers of that audio. So ultimately that broadcast output has to be orchestrated and maintained by a network. And what this document that the AES working group is really working on is really the best practices for, well, how do I distribute a clock? What is a clock? How do these regions need to absorb clocks, and how do these regions need to participate in these clocks? Again, these regions are little tiny data centers themselves. So to be able to move it locally and then move it nationally becomes a very important technique and trick of some of these machines. So a lot of these machines and a lot of these FPGA-based I/O boxes, gateway boxes, do hook up to computers with sound cards and virtual sound cards, and there are dependencies, other clocking mechanisms, PTP. So there's a need to fully understand the complexities, and the document of this working group, takes a stab at it in a great and effective, very effective way. And again, like I said, multiple links. We are a consumer. We are broadcast is a school of redundancy, and when it's 999, you're dropping millions of packets per second. Like it all adds up. AES standards, those are the things that we consume as broadcaster in order to make your everyday TV, your everyday radio work. Now what we're trying to do is more national collaboration on all of these things, and we want to do it as best quality as we possibly can, and we rely heavily on AES standards to do this. I would love to talk about our Montreal project and what we're doing with 2110 and the dual link redundancies of AES67. But I thank you all for the opportunity to speak here. I know Olivier has some real life examples. I hope to speak at a next one of these with a real use case, and thank you very much. And I'll stop my share and yield my time.
Thank you, Anthony. This was really interesting.
Yes, thank you. Yes, the translation I think is working. So. Thank you, Anthony, for this presentation. So I'm Olivier Chambin, welcome, and I'm audio broadcast engineer in charge of audio over IP and voice over IP for Eurosport Discovery. So I would like to talk to you of the ETT project developed by Eurosport. So it's all the transition to the IP world, so for the video and for the audio. And I would like to explain how we did that, and what is the problem we can have when we go on a real life with a project over IPs in the broadcast. So please, can you show the next slide? Thank you. So Eurosport is a 24/7 live sport broadcaster. We have we have locations based in all the countries in Europe, and we broadcast in Europe, in Asia, and Pacific. Eurosport produced in 21 languages, and each country have a specific version, so that's a total of more than 60 different playout channels broadcasted over Europe and Asia. Plus, we also have a 100 digital events feed broadcasted on Eurosport Player platform and Discovery Plus platform. So how it's working? We have in different markets commentary position, and also technical operation with a sound control room, with video facilities, etc., etc. And all of them are connected together through a WAN and connected through this one to two different data centers. We have data center A in Amsterdam, Netherlands, and the second in London, UK. Why we have two is only for the redundancy. On these two data centers, all the audio process, video process, graphic process is done inside. And on the local markets, we have only control for the audio mixer, control for graphics elements, etc., etc. Plus some contributions feeds. So we have the video contributions feeds for monitorings, plus the monitorings for the sound operator, the clean commentary coming from the commentary position or coming from the different test box in the studios. When we are in a situation on site, so if you go to the next, please, yes. So we can have facilities on the different events. For example, during tennis Grand Slam, Australian Open, Roland Garros, or major events like Olympic Games, we have direct connection through the tech hubs. Next, please. Yes, so we have direct connection between the OB-WAN or the IBC's facilities connected through this tech hub. So that means when we have commentator on site, when we have studio, etc., we are directly able to receive the stream and process them into the data center and control them in the different locations in Europe. So next, please. Yes. So how it's work? We have, as I said, both data center. All of them are connected through the WAN, and the connection is dual attached. So that means we have path A and path B, and in case of failure, we can continue to broadcast and to produce on the second path, and that's is very interesting because we can continue to produce without any hit on the transmission. This network is based on the MPLS architecture and is hosted by different providers. So it's a private WAN networks. The different contributions crossing these networks are SMPT 2110 based streams, so for the video and for the audio. And due to the topology, dual topology with the path A and the path B, we are using the SMPT 2022-7 standard to have the seamless protection between the path A and the path B. Of course, we have audio and video devices working together, so the synchronization is very, very important, and that's why we have a sync distribution based on PTP-aware switches, plus a local PTP distribution, as explained by Nicolas just before. So in some markets, it's sync. We have a sync reference based on the GNSS reception, but when we are not able to receive a signal coming from the roof, or if we have a storm, or if we have a disturbance, we can use a unicast distribution between Grandmaster on the different locations. So next slide, please. So this project was based on an existing network. So Discovery already have a network able to support multicast traffic and massive distribution platform. And due to the geographic distance, one main challenge was the delay. because we are between 4 milliseconds and 150 milliseconds when we are broadcasting to Tokyo for the Olympic Games, for example. So important thing was the capacity to support high buffer and the PTP distributions. The main project goal was also to be fully compliant with the SMPTE 2110 standard, to be compliant and interoperable with video devices. So that's why we decided to be as close as possible to the AES67 standard. And of course, one important thing is the control and the management of all the stream via orchestration and NMOS protocol, plus the security aspect. Next, please. So another element interesting on this project is the virtualization. So we have on the tech hubs a pool of virtual machines, and on this pool of machine hosted, we have audio process, mixer, audio sequencing, and all is managed by the hypervisor. So in case of system failure, OS failure, frame failure, hardware failure, or switch failure, we are able to move the system to another location on another system from via the hypervisor, and we are able to do that in more or less 160 milliseconds. So that's 4 frames on the PAL reference. So that's very interesting in a 24/7 architecture when we are live all the time. So next one. So Eurosport broadcast and have some production on air using AES67 since 2018 since the Olympic Games, and we are now fully compliant with the 2110 standard for video, and we broadcast video 2110 since last year. So thank you.
Thank you, Olivier. This was also very interesting. So those user feedback, they are the backbone of our standardization group, because once AES67 is written as a standard, it becomes important to follow the very expectations of our users. So now, what to expect on this project? So as I said before, we are on the last stages of the first draft, and it will be outputted as a report with a lot of analysis and problems pointing out to learn and to solve. There will be open questions, but there will be also a lot of information for newcomers to the wide area network world, and mainly if you're an AES67 users, you are used to using local area network, not necessarily wide area networks. So this will be the difference. Of course, the first output is a technical report. Then, based on the return that we will get on the feedback on this technical report, it may or may not evolve into a standard reduction of or improvement. So that's it. That's it for the presentation. Let me just not share anymore. And so now we are open to questions. So while we are waiting for the first questions, of course we had many more users giving us feedback during this those meetings of the committees, and mainly there was feedback from the BBC, from Germany, the IRT, from Switzerland. We had also feedback from private companies who shared their experience with us. And so I have a question from Jamie. This is for you, Olivier.
Yes, so how do you distribute PTP? Do you always rely on GPS? So basically, due to the distance, we have a local PTP generator reference on the GPS on each location, and we only share the PTP locally because PTP cannot cross the one. But in case of failure or when we are not able to have a GPS reference, we are also able to send a reference from another grandmaster to another to the synchronization to the generator via unicast reference. Because PTP is also working on unicast, but the end devices are not able to support it all the time, so that's why we can directly send it between two generators.
Okay, thank you, Jamie, for the questions. Yeah, so we had contributions for one interesting contribution was from the Swiss TV, who is using a wide area network all over Switzerland, and all those contributions should be in the final document from the working group. So if you're interested in that, I'm kindly asking you to wait for us to release the first draft of the document. And Anthony, while you are laughing, please shut your camera because.
Well, you know, it's a long process. You know, it's very interesting. You know, like to see the revisions, the reviews, the feedbacks. It's very interesting to watch devices kind of evolve from a user point of view. I know Olivier can attest to, you know, some of the early starts of getting this stuff operational for broadcast. You know, there's been some monumental change and development for the standards group, and it's really a privilege to have groups like this where we can discuss this topic. And I'm laughing because, you know, people think it's just going to be like overnight, and it's like, all right, it's installed on that machine now, like it's on that one. Like you say you're AES67 and blah blah blah, you do all these things, but it's not that. And people need to realize that it is you know, I am not the only person at the CBC. Just like you look at those drawings, you know, Olivier is not the only person, you know, doing those things. These things are massively scaled with multiple hundreds of human beings attached to making it happen. So, you know, I have to laugh because it's always about connecting people to make deliverables, and the document is one of those things that, you know, it's been fantastic to connect on.
Yeah, I agree with you. Of course, we need to first have a very good team, and it's a pleasure to work with them every day in Eurospot and Discovery because they have a lot of skill. But that's also an exchange with a vendor, because of course you cannot buy the devices on online and put it on the rack and turn on. It's not working. So that's every day an exchange with a vendor to have a maximum of interoperability between the devices, because that's the only possibility to connect everything together without using gateway all the time.
And from the ground up, from the start of the development of this standard committee, the role of the broadcasters and the users in a wider sense has been really important in shaping and steering the committee in the right directions, in addressing the right problems. And of course, this was the whole question starting for this very AES67 Beyond the Ground project. Okay, we have COVID, we are asked to stay at home, but we need to produce content, we need to contribute, and we need AES67. So I even had in Merging Technologies, I had customers just sending me emails and asking, how can I do that? Can I put AES67?
Why doesn't it work? I got this plugged into my router at home. How come it doesn't work? How come I don't see
exactly.
it? Why is it not being discovered? It's just like, whoa, hold on. Let me just walk away, because it's going to be too hard to explain. And that's really kind of like the purpose of this document is like, it's really like, it's not like an off-the-shelf type of solution, right? And I think that's really, something that people need to understand, that like this is emerging technology, like this is groundbreaking, pioneering type of stuff, and in the broadcast world, there are pipelines and bandwidths and network and support to deliver this type of technology in multiple places across, countries, provinces, etc. So, and there's a real cost associated with moving this amount of data too. Like there is a lot of data to move between locations, and like you say, Nicola, like customer support would be very interesting to see how they do this, and there have been other workarounds, but really, for the Olympics, we're broadcaster of the Olympics as well. We everything has to be time aligned and everything has to be synchronized, and what really sets AES67 2110 apart, and the thing that's been of great discussion in these sessions has been timing. And we have a lot of shepherds of time. I think there are like people like in our working group there, I'm going to call them shepherds of time, who come in and they ensure that we are all agreeing on these terms, because in the document that we're presenting, it's accuracy is the key to interoperability. So sorry, I yield. And sorry, Nicola, I've talked for days.
Yeah, but that's really interesting. Thank you, Anthony. And that's really right. The art of the interoperability is both sticking to the definition of what you give in the standard, and yet being permissive enough to allow different interpretations into this. And so it's very interesting, of course, but it can be really tricky. And all those
it can be tricky, and really, the higher you pay for a device is really, it comes down to capabilities, right? And like a flexible receiver, like, nobody's saying you have to do this. What they're saying is it would be nice if you could receive all of this way.
Yeah, and that's what, let's end off this those simple words, best practice. It's all about the best practice, because you can do so many things with all the tools that are listed in AES67. And by the way, AES67 is a list of already existing standard, and just a recipe, a cooking recipe, as some of us say. And I don't know if you're on the call, Andreas, but this is a phrase that Andreas is using often, Andreas Hildebrand. And so it's a recipe. And of course, you can digress from your recipe, but the best practices, those are the ones that are important on the RAN and paramount on the WAN, because you are sharing infrastructure with many other things, and sticking, looking, and learning those best practices that are from the IT world since 25 years. Those will be the keys for the adoption of media network in general, and of course AES67 in particular.
Yes, and that's an interesting thing. When we are working with IT teams, we need to consider that they need to have media knowledge. So they need to understand that you are working 24/7. In my case, we are using multicast, so it's not very easy to consider. It can be tricky. That can have a lot of impact on the usage of AES67 on a platform. So that's why sometimes I can understand people saying, okay, I prefer to use a gateway. I don't want to go on IP, or just have an IP network, but use a grid on the front of the system. And that's of course a question of knowledge, and we have more and more now people able to work on this type of platform. But of course, that's also because we have more and more projects like Eurosport, like CBC, on air and working.
Yeah, and I also saw in the audience some people that are teaching, and that are and it's important as well. It's about teaching the best practices, teaching the protocols, and of course making the difference between what you can do with a lot of time, which is AES67, and maybe some other protocols that can allow you to have a quicker results, but not necessarily as flexible as it is with, or as it could be with an AES standard.
When we have to ask for them as consumers, right? You know, when we put out purchase orders and purchase requests, we can simply state AES3 compatible, and we can simply state, you know, protocol implementation conformance sheets must be provided. So as you're purchasing and as you're building these networks, these are normal questions to ask vendors nowadays. The PIX has been around for, you know, almost 2 years now. It's been a discussion for almost 5. So if you have an AES67 device, that you've been part of that discussion. So I have to commend you again on the work and the leadership, Nicolas. It's been a fantastic privilege to be a part of this, and thank you again.
It's not over yet, so there's still
It's like a 2-hour thing. Do we have like 2 hours? Come on.
No. I mean, the webinar is over now, but the project is not. So you will have to bear with me for some months again. Okay, everyone. Thank you for attending. And you were many, like I saw 50 people at a peak, and now only 36 left. But that's when Anthony is talking. Some people are used to leaving the. You are.
Yeah, totally. I always say everybody trails off with me. So
no, I was kidding.
Join us for the Toronto AES noise, and you know, to torontoaes.org/noise if you would like to watch a presentation. Yeah, I always got to put a plug in. Absolutely.
Bye bye.
Thanks.